Hello students, today we are going to discuss the paper of matrices and determinants. So here let us start with the first question. This paper was conducted on I think 19th of April, I guess. So let us start with the first question. If A is a matrix of 2 cross 2 such that A into this 1 minus 1 column matrix equals to minus 1 2, and here A square, the same column matrix you have to multiply and you are getting 1 comma 0, then trace of A, where the trace of, what is the trace. So here A is a 2 cross 2 matrix. Let's assume that A is A B C D. Okay, so trace of A will be the sum of the leading diagonal elements, that means A plus D. Okay, so A plus D you have to find. For that we need to find the A matrix. Okay, so this A matrix you can multiply with 1 minus 1 and you should be able to get minus 1 2. So if you multiply on the left hand side, you will get A into 1 A, B into minus 1 minus B, and C minus D equals to minus 1 and 2. So you will get two equations, A minus B equals to minus 1 and C minus D equals to 2. Okay, so these two equations and four variables, but we have another matrix equation, this one. So here you will need A square. So A square will be A, B, C, D and A, B, C, D. A into A. So A square we can write here as A into A will be A square plus B into C. You know the matrix multiplication nicely. So this will be AB plus BD, and this element will be CA plus CD and BC plus D square multiplied with 1 minus 1 equals to 1 comma 0. Okay, so from here you will get two more equations in ABCD only, and you already have these two equations. Solve them. Okay, solve these four equations and you will get A, B, C, D, all the terms. Okay, and then you will be able to find trace by adding A and D. So trace of A matrix will be A plus D, and you can find that this will come out to be 1. Okay, so here the option A will be correct answer. So this solution you can do. Let us move to next question. Here A equals to ABC, BC, CAB. You can see that it is a symmetric matrix where ABC equals to 1, A transpose A equals to I, then the value of A cube, B cube, C cube you have to find. So this is a very classic question. Okay, so this uses two formulas, algebraic formulas. We will see. A transpose is a transpose of matrix A. We already know that. So here A transpose A equals to I. We will utilize this equation. So A transpose will be, so first let me write A transpose A equals to I. We are using this equation here. So this will be A transpose will be ABC transpose of this matrix, which will be same because it is a symmetric matrix, you can observe. And then A, so that will be ABC, BCA and CAB. A transpose A equals to I. I means identity matrix. So when you multiply these two matrices on the left hand side, you will get some equations. So let us try to find the first term. So this will be, if you can find out, A square, B square, C square. And if you multiply first row with second column, you will get AB plus BC plus CA, and similarly here also AB plus BC plus CA. Okay, and here BCA, ABC, so this will be again BA or AB plus BC plus CA. This will be A square plus B square plus C square. Here also AB plus BC plus CA. Okay, here also A, B, B, C, C, A, A, B, B, C, C, A, and finally A square plus B square plus C square, and this will come out to be 1, 1, 1, 0, 0, 0, 0, 0, 0. Okay, so from this matrix equation, you get two equations, A square plus B square plus C square. If you compare, that will be 1, and AB plus BC plus CA will be 0. Okay. Now we need A cube, B cube, C cube. So for that we will use one formula. But before that, let us use another formula, which is A plus B plus C whole square. So this comes out to be A square plus B square plus C square plus 2 into AB plus BC plus CA. Okay. And here AB, BC, CA is 0. So that means A plus B plus C square will be equal to A square B square C square, which is 1 only. So this is 1. A plus B plus C. This is square. So root can be plus 1 minus 1. But they have given A B C greater than 0. That means A plus B plus C cannot be negative. So A plus B plus C will be positive. This we have concluded. So A plus B plus C is 1. Now let us do this one. The formula including A cube, B cube, C cube. So that is A cube plus B cube plus C cube minus 3ABC equals to A plus B plus C and A square plus B square plus C square minus AB minus BC minus CA. Okay. So this AB, BC, CA comes out to be 0. This A square, B square, C square comes out to be 1. Yes, from the equation itself, matrix equation, and ABC is 1. We concluded. That's why we used this formula first. So A cube, B cube, C cube minus 3 ABC. ABC is also given in the question. Yes or no? So here 3 into 1, and this is also 1. This is 1 minus 0. So on the right hand side, this is 1. And this minus 3 will go on the right hand side, adds up. So this will give you 1 plus 3, 4. So option D will be correct. Okay. Let us move to next question. Here A is a square matrix supported 2 cross 2. B is this such that AB equals to BA. So you can assume A has to be, let's say, A, B, C, D. Okay. And you will get, through this equation, you will get 4 equations basically. So AB, if A is A, B, C, D, and B is 1, 2, 3, 4. BA means 1, 2, 3, 4, and again A, B, C, D. Okay, so this will come out to be A plus 3B and 2A plus 4B. So similarly, you can find this matrix, okay, and equate the corresponding elements. Okay, and then you will find the value of A, B, C, D, and from that you can find the matrix A. Otherwise, you can also do this thing that assume that this A option is the correct one, and by assuming this, you multiply this AB and conclude that assume that this is A, this is B. So find AB and then try to find B into A, BA, and then see whether this option is holding or not correctly. So you will get actually this option only, option A. You can check other options, they will not be valid. So from here also you can find ABCD and find the matrix A, or you can check the options also in such a simple question. Okay, let's move forward. And this is your a square matrix A of order 3 satisfies A square equals to I minus 2A, where I is an identity matrix of order 3. If A power n equals to 29, A minus 12i, then the value of n is equal to. So here we have already this A square equals to I minus 2A. No other information is there. So we will utilize this one only. And yes, I is a identity matrix of order 3. Okay, and here a power n. A power n equals to 29a minus 12. So in this type of question, what you have to do is just find a power 3. Okay, so that will be a square into a. That means I minus 2a into a. So a power 3 will be, if you multiply a, so this will become a minus 2a square. A minus 2. A square is again I minus 2. So this will become a minus 2i plus 4a. So this will become a power 3, 5a minus 2i. Okay, so here we can see that this is not what we expected or hoped. So 5a, here it is coming 29a minus 2i, here it is 12. So we can find a power 4 or a power 5. We will have to keep finding because options include value of n as 3, 4, 5, 6. So 3 does not match. 4 you can find. I will try to find a power 5. How can you do that? That you can do by a power 3, a power 2. Okay. A power 4 you can find by multiplying a here. So that will become. So a power 3, 5 is a power 3 minus to a power 2. So this will become a 5a minus 2i from here a power 3. And then a power 2 is given in the question 5 minus 2. A power 5 will be 5a minus 10a square minus 2i square, that means 2i, and plus 4a. So here a square you can write again as I minus 2. Yes. So we have to keep utilizing that equation. So here 5a minus 10i plus 20a minus 2i plus 4a. So you can see 20a, 5a, 25a plus 4a, that means 29a, and minus 2i minus 10i, so minus. Clear? So let's move to next question. Here, let A equals to 1, 2, 3, 4 and B equals to A 0, 0, B. A, B belongs to natural number. Okay. So here AB equals to BA, AB equals to BA, AB equals to BA, AB equals to BA. So all the equations are containing AB equals to BA. Okay. So there we have to find the equation condition. There cannot exist any B such that AB equals to B. There exists more than one. Okay, so about B matrix we have to find. Yes, so here in the last question the answer will be C option. So here let us calculate AB equals to BA. So A is 1, 2, 3, 4. B is A0, 0B. Then equals to BA. BA means A0, 0B into 1, 2, 3, 4. All right. So this becomes 1 into A, 2 into 0, that is 0. So this becomes 2B. Here 3A and 4B equals to A 0 into 3, 0. A0 with 1, 3. So this will be A into 1 and A into 2. So this will become 2A. Okay. And 0 into 1, 3 into B and 4 into B. So if you compare this 4B, 4B same, A into is A equals to A same. But from here you are getting 2A equals to 2B. So this means A equals to B. Okay. And from here also you are getting A equals to B. 3A equals to 3B, A equals to B. So here you can see that if A equals to B, you put in the matrix A, that means B will be, okay, let me write completely. So B will be A0, 0A, and you can write B as taking A common, so 1, 0, 0, 1. So this will become B equals to AI. Now this A is a natural number, so with changing A, you will have B as B will also be changing with A when A is changing. So you can have any number of values, infinitely many number of values. Okay, for A and B equals to AI. So there will be infinitely many B's such that A B equals to. Okay. So D will be the correct option. Let's move to the next question. Here they are saying A is a symmetric matrix, B is a symmetric matrix such that A plus B equals to this. Then AB you have to find. So you know that any matrix can be written as the sum of symmetric and symmetric matrix. Let us talk about X matrix. So this can be written as X equals to 1 by 2 X plus X transpose plus 1 by 2 X minus X transpose. So here if you observe that this first part is your symmetric part, okay, first part is symmetric part, and they have given A as symmetric part. That means this part we can safely call as A, and this is skew symmetric part. Okay, so we can call this second skew symmetric part safely as B matrix. Clear? So now we can find this A and B, and then we can multiply A into B. So what is A? A will be 1 by 2 X plus X transpose. What is X matrix? The actual matrix, because that only we want to split. So this is 2, 3, 5 minus 1, and then X transpose. So that will be 2, 3, 5 minus 1. Okay, just taking the transpose. So here you can find this A matrix. Let me just multiply it directly. So this will be 2 into 2, 4, 3 into 3, 9. So 4 into 9 will be 13. Here 2 into 5, 10, minus 3, 7. And then 5 into 2, 10, minus 3, 7. And here 5 into 5, 25. And plus 1, so 26. Okay. So like that you got this A matrix, you can multiply this 1 by 2 inside, or you can keep it as it is. So here you can find again B matrix, which will be 1 by 2 X minus X transpose. Oh, this will be X plus X transpose, sorry. These will not be the elements actually. So this is your X plus X transpose. So you can add directly 2 plus 2, 3 plus 5, 8, 5 plus 3, 8 minus. So this will be the answer. And then here 2, 3, 5 minus 1 minus 2, 5, 3 minus 1. And then you can find this 1 by 2, 2 minus 2, 0, 3 minus 5, minus 2, 5 minus 3, 2, and this is 0. So this is your B matrix. Okay, so you can multiply now and find the answer. That is a very easy task for you. So you will find that B option is correct here. Let us move to the next question. This is a little tricky question, but we can find the answer. If fx, gx, and hx are three polynomials of degree 2 means this fx can be of the form ax power 2 bx plus c. Okay, and gx also same, hx also. And then we need f dash x also. So this f dash x, if you check, this will come out to be 2ax plus b, and then we need f double dash x also. So this will come out to be 2a. Please try to understand this nicely. So this will be degree, this will be a equation of degree 2, this will be a equation of degree 1, and this will be a equation of degree 0. Okay. So here, if you try to find the determinant x, because that's what we have to calculate, what can be the degree. So delta x. So I will write fx, not as fx, but I will write this a polynomial of degree 2. Okay. And then let's call this gx. So I can call this as df of degree 2, this as dg of degree 2, because they have given that this gx, hx are also polynomial of degree 2. So polynomial degree 2. Then if you check the first order derivative, so then this degree will reduce. So this will be df1, dg1, and then dh. Clear? And then this will be df0, dg0, and dh. If you try to see this, what is this? So if you expand the first term, you will observe something. So that will be df. I am expanding along first row. So df degree 2 will be equal into df dg1 dh0 minus dh1 into dg0. Okay. So from here you will get that this is a polynomial of degree 2 outside the bracket, and inside we have full this term. So this dg is a degree of polynomial 1 and this is polynomial 0. So this full term will come out to be degree of, let us say, polynomial gh as 1, and this also dhg of 1. But this there is a minus, so it is not necessary that they will be same. Okay, it may happen in some cases, but not necessary. Okay, and outside we have degree of polynomial 2. So here at most we can see that finally this will be a polynomial of degree 1, and this outside is of polynomial of degree 2. So at most it can be 3 degree polynomial. It can be minimum also if this becomes, if these two terms becomes same, then this will be 0, that means polynomial 2. But maximum it can only have 2 and 1, so degree 3 at most. More than this is not possible. Less than this is possible, but more than this is not. Let us move to question number 8. The system of equations, this, and this is consistent. You can see that this is a homogeneous equation, means trivial solution and non-trivial solution also may be present. So here we will try to find the determinant value putting to 0 and then relation between A, B and C. Yes. So let us start the question. One more thing here, this is a little tricky. So these they have given as 0. So let us see what it actually is. So x plus y minus 1. So minus 1 goes there, so it becomes plus 1. But there is no component of z. So what we will do is we will put 0 into z equals to 1. Okay. Here 2x minus y minus c equals to 0. So 2x minus y plus 0 into z and minus c will go on the right hand side. Here b, so this will become minus bx plus 3by plus 0 into z equals to c. Yes. So here you can see that z components are 0 and this constant, this is not a homogeneous, so this is 1cc. Okay, and this is consistent. So for consistent, because if you observe the determinant here, determinant will be coefficient of xyz, so that will be 1 1 0, and here 2 minus 1 0 minus b 3b 0. Okay, so this determinant is 0 because you can see that third column is 0. Okay, now so d is 0. That means unique solution is not possible. That means that only infinitely many solutions are possible. Only that is the case, because determinant is 0, that means unique solution is not possible, and consistent means having solution, that means infinite solution is possibility. So d equals to 0. For infinite solution we need d1, d2, D3 also to be 0. Okay. So if these have to be 0, that means we have to write D1. D1 will be how much? If you observe, that will be your, you just have to remove the elements, the coefficient of x from the column 1 and put the constants there. So 1 C C, rest will be same. Rest will be same. So you can see still the third column is 0. That means this will be 0. And if you observe the D2, that will also be kind of same because here you replace the coefficient of y with the constants. So this will be 1, 2 minus b and 1 c c, and this is 0, 0, 0. So that then it becomes 0 because third column is 0 here. Let us check now D3. In D3, there will be an interesting case because here you replace the 0, 0, 0 with 1 cc, and rest will be same. 1, 2 minus b, 1 minus 1, 3b. And this should be 0 for infinitely many solutions because for infinitely many solutions, this is the condition. So here you try to expand. Okay. So we can expand this easily and then you will get some equation. So I will write the equation directly. Okay. So you will find that the equation is coming out to be C3 plus 4B equals to 5. Because we need the condition on B, okay, so we will try to find this full equation in terms of B. Why? Because they have given condition on C already. If C is less than 1, that means if C is less than 1, then this equation in B is also less than 1 only. So here you can write as you can write it as like this 5b upon 3 plus 4b, 1 you take here, so this will become less than 0. So 5b minus 3 minus 4b, I'm taking the LCM, so 3 plus 4b less than 0. So this will come out to be b minus 3 divided by 4b plus 3 less than 0. So this is a simple inequality equation, inequality. So here you can find the interval for b. How? Just find the roots first, 0. So b minus 3 equals to 0 means b equals to 0. And from here you will get minus 3 by 4. So first we will write minus 3 by 4. Here b equals to 3. And you need the negative, means this portion will be your answer. So b, you can check. This will be positive, this will be negative, this will be positive. Okay. So this will be how much? Minus 3 by 4 to 3. This is your final answer for B belongs to minus 3 by 4 to 3. Let us now move to the next question. It is also a little tricky. So here delta x equals to x power n factorial a sin x sin n by pi by 2 a square. And then here also. So you have to find d and dx power n at x equals to 0. Okay. So in this question, you will try to assume n equals to 1, n equals to 2, n equals to 3 like that, and you will try to find the solution. So if n equals to 1, what will be the scenario? Oh, sorry, not 0, n equals to 1. So this will come out to be delta x equals to x, 1 factorial is 1, and this is a sin x sin pi by 2. This is a square cos x cos pi by 2 a power 3. This is x sin x cos x. This is 1 0. Oh, pi by 2 is 1, not 0. This is 1, this is 0, and this is a square a power 3. So this is your delta x if delta n equals to 1. There we need to find just d delta x by dx. So d differentiation of delta x by dx. and at x equals to 0. So we will do that also. So first let us find out this one. So this will come out to be 1 cos x minus sin x, and this other rows will be same as it is. So you can differentiate one row or one column at a time only. So this is the first differentiation. Now we need to find the value. Yes, and the other rows if you differentiate, because this is also constant, like third row is also constant, so they will become zero directly. If you differentiate with x, that will be zero. Constant differentiation is zero. So all the other determinants, two more will be there. Differentiation of second row, differentiation of third row, they will become zero. So I am not writing that. So here, if you put x equals to 0 now, okay, so you will see that differentiation is becoming 0 again. So d delta x by dx at x equals to 0. So this will come out to be 1. Cos 0 is 1 minus sin x. So that will be 0. 1, 1, 0. A is square a power 3. And you can see that row 1 and row 2 are identical. So this will be 0. Similarly, you try to find n equals to 2. For that also, differentiation of delta x by dx at x equals to 0. That will be basically d2x by dx square. You can do that and you will find that the answer will be. Okay. So you can proceed now. Let us do this one, and this is the easiest question I hope in this paper. So A is this, B is this, A square is B. So we have to find the value of alpha for which A square is B. Okay. So let us find A square is how much? A is alpha 0, 1, 1, and B is 1, 0, 5, 1. So this is O. Okay, I will make it A square equals to B. So this is again alpha 0, 1, 1. So this is your A into A equals to B. Okay, A square equals to B. So here you can see that alpha into 0. So alpha square 0 into 1, 0. So this will be alpha 0. Okay. Alpha into 1, 1 into 1. So this will be alpha plus 1 and this will be finally 1 equals to 1, 5, 0, 1. So if you compare alpha square equals to 1, okay, so from here you will get alpha equals to plus minus 1. And if you compare this element, so alpha plus 1 equals to 5. So alpha will be 4 here. You can see that you are getting two different values of alpha, which should not be the case, because if you put alpha equals to 1 here, so this will become 2. That means this equation is never satisfied for any value of alpha, so no real values of alpha, the easiest question. Here, this is also very easy, p by q. So here you can expand the first row, that will be a power 2x plus a power minus 2x plus 2, because a power x, a power minus x will become 1 only. And here also b power 2x, b power minus 2x plus 2, c power 2x plus c power minus 2x plus 2. Here on the second row, we have to expand again. So here a power 2x and a power minus 2x minus 2, b power 2x plus b power minus 2x minus 2, c power 2x plus c power minus 2x minus 2. This will be 1, 1, 1. Okay. And if you now do this simple column operation, C1, C1 minus C2. So you will observe that in column 1, you will get these terms cancelled. And 2 minus minus 2 will be 4. Here also 4, here also 4. Second column, you don't even need to write again. You can just notice that first column and third column are identical. And if any two rows or two columns or three columns are identical or equal, proportional, then the determinant value is 0. So answer is 0. Let us move to next question. And that is this one. This is also very easy question. You just have to expand. So you directly expand this delta 1. So delta 1 you can find, which will come out to be first delta 2 you can find. That will be the easiest. So delta 2 will be x into x square minus AB. Yes. So this is the delta 2. And what about delta 1? So that will come out to be x power 3 minus ABX. Okay. Plus AB square plus A square B. So this will be your delta 1 actually. Minus 3ABX. So here you can see that which option is matching. So delta 1 equals to 3, delta 2 is square, delta 2 if you do is square, so there will be so many terms and you will get x power 4 not x power 3. So this is the case. Differentiation of this delta 1 equals to 3 times delta 2. So differentiation could be there because this is x power 3, this is x power 2. Let us check. So if you differentiate delta 1 with respect to x, so this will come out to be 3x square minus 3ab. This will become 3x square minus ab. Okay, and you can see, observe that this x square minus ab is delta 2. So this differentiation of delta 1 is 3 delta 2. That means B is the correct option. Okay, quickly and easily you can see that. Let us do this question very easy again. So this is f0. So you just find this determinant when x equals to 0. So 0, 2, sorry, 2 and 0, here 1, 0, 4, here 1, 6 and minus 2. And then you can multiply it by 2 also. So twice of this will be this much. So you can calculate and this will come out to be as 2 into f0. So this will be your 24. You can calculate this determinant easily. Just expand by first column. Okay. And then this f dash 0. So first differentiate the determinants and then just put x equals to 0. So f dash 0 will come out to be your 18. Okay. Very easy to differentiate. First differentiate by first row, second row, third row. Okay. I will just differentiate it for you once. So let us calculate f dash x first. So that will be how much? See, x cube differentiation 3x square. I am doing first row differentiation 2x square plus 1 4x. This will come out to be 3. Yes. And in second row will be same. And third row will also be same. Minus 2. So this is the differentiation of first row. Now you will put a 0 in the next step and you will get this as 0 2 0 0 0 4 3 6 minus 2. Then you will get another determinant where you are differentiating the second row. So that will be 6x 2 3x square. Rest will be same. Okay, as in the determinant. There also you will put x equals to 0. Then differentiation of second, third row, that will be 3x square minus 1, 4 and 2x. First and second rows will be same. There also you will put x equals to 0. So you will get f dash 0 as 18. Okay, so this answer will be, so full will be 24 plus 18 and that will be equal to 42. C option is the correct option. Let us do now question number 14, but here the question is incomplete. Fx equals to this determinant, then. So after that, they have not given anything. So this question is incomplete. we are not sure what they want to ask, so you can just skip the question. Let us do question number 15. So here you will have to just apply some operations like row 1 minus row 2 you can apply, or row 2 minus row 1. So then you will get some terms as 0. 3 by 2 minus 1 by 3. This will become, I guess, you can check 3 by 2 minus 1 by 3. So this will be 6. 9 minus 2, 7 by 6. Yes. So 7 by 6. And this is alpha plus 3 by 2, alpha plus 1 by 3. So this will also give you 7 by 6. Rest will be same. So like this, you can apply operations like we got to learn in the class. And from there, you will get this equation in alpha. Okay. Finally, when you expand after doing some more operations, okay, so you will get one equation that will be 2 alpha square plus 6 alpha plus 1 equals to 0. From here, you can find alpha as using the quadratic formula 3 plus minus, or I will write the roots differently. Okay. So this alpha will be minus 3 plus root 7 by 2, and another alpha because you will get two roots. That will be minus 3 minus root 7 by 2. And if you observe that root 7 is a little around 2.6, so your alpha will come out to be this alpha will come out to be your minus 0.18. You can calculate, and this alpha will come out to be minus 2.82. Okay, and then you can see that this which interval this alpha will be lying. So that will be your, I guess, this one. Yes, minus 3 to 0. You can see that minus 3 to 0, it will give you the correct option. Yes. Let us move on our next question. That is a very tricky question. So this is A, this is P. The sum of prime factors of P inverse AP minus 2i. So one idea could be find the inverse of this matrix, then multiply A, then P minus 2i. Okay, but here what you can do is you can write I as P inverse P, because you know that P inverse P will be I only. So here you can write P inverse AP minus 2I P inverse P. Okay, so now you have to find this. You can find P inverse common, P inverse AP, and from here 2P. Yes or no? And here P inverse this, if you take P post multiplication common, so this will be A minus 2I, and this will be P, and you can split the terms P inverse, this will be A minus 2I and P determinant, and you know that in determinant of P inverse will be 1 by determinant of P, this will be A minus 2I, this will be P, so this is gone. The determinant of A minus 2I you need to get. You can do that because A you know, and identity matrix you can write. So this A minus 2I determinant will be, I will write the determinant directly. So you will have to subtract 2 from every diagonal element. That will become 0 because already 2 is here. So 0, 0, 0. This will be 1, 2, 6, 11, 3 and 3. So you can calculate this. This will come out to be your 26 and the option. Okay. Let us move to next question. This is also a little tricky. C is AB, A transpose, and X is A transpose C square A, then determinant of X is equal to. Yes. So in the last question, you need to find the sum of prime factors. So here prime factors will be how much? 3 and 12. So this is a prime. Sorry. 2 and 13. This is also a prime number. This is also a prime number. Oh, I'm very sorry. This determinant value will not come out to be 26. Rather, it will come out to be 69. Okay, 69. So here the prime factors will be 3 into 23, you can see. So prime, these are prime numbers. Okay. And you know that one will also be a factor, but that will not be a prime factor. So we need just some of prime factors, not just any factor. So prime factors will be 3 plus 23. That will be. If we were talking about normal factors, so that will be 3 plus 23 plus 1 also. But here only prime factors, that means 26. If you are talking about simple factors, then the answer will be 27. But here prime factors, so let us move to the next question. Here determinant of x. So that we can find out by first calculating c square. Yes. So how much will be the c square? C is AB A transpose, AB A transpose. So C square will be AB A transpose A B A transpose. So C square will be A transpose A is how much? Can calculate this. So A transpose A, if you calculate, this will come out to be 3i. Very simple calculation you can make. So AB 3i and then B A transpose. 3 can come out common. So that will become 3A B square A transpose. And what about B square? If you calculate B square, this will come out to be 1, 0, 2, 1. Okay. But we will keep that as it is for now. We will use that later. So C square we know. Now we need X, basically determinant of X. So X will be A transpose. C square is how much? We will write it here. AB square A transpose and then A. So this will be X A transpose. 3 you can take out. So 3 A transpose and actually A here. Yes, this A and then B square and then A transpose A. Okay. So if you know that A transpose A is 3i, then you will find that A transpose is equals to 3i. Okay, you can check that. So here this will be 3 A transpose A 3i, then B square, then A transpose A again 3i. Okay. So this will be basically you don't need A transpose, you need only A transpose A. So this 3, this 3, this 3. So this will become 27i and then B square only. So B square now you can find 27. B square will be how much? If you find B square will be your 1021 and this will become 27 0 54 27. Okay, so determinant of x will come out to be 243. You can calculate this determinant as 27 square minus 0. So 27 square is 23. Sorry, 243. Okay. Next question. Here we have A matrix as this matrix x, y, z equals to 60. 8x plus 4y plus 3z equals to 20. They have given. We need to find A adjoint A. And we know that A adjoint A is given by determinant AI. Okay. So we just need to calculate the determinant here. What will be the determinant value? Let us find out. So here, if C, the determinant value will come out to be, finally, will come out to be x, y, z minus 8x plus 3z plus 4y. You can calculate this, expand this determinant simply. So x, y, z they have given as 60 minus 8x, 3z plus 4y. They have given as 20, then 28. So this is 40 plus 28. So this is 68. Okay. So we need to calculate 68i, and that is basically 68,111,000,000. So this will come out to be 68, 68, and 60. So here the answer will be C option, rest will become 0. Very easy, but a little tricky if you don't know this one. Let us move to the next question. This is a expansion splitting of determinant basically. So this D is okay. This D you can keep as it is. So this D you will find, sorry, this D dash you have to calculate. But first you have to calculate the determinant value. Okay, you keep splitting this. So this determinant value, oh, this is directly D dash. So you can split this directly. So this you will find as D plus PQR into D. Okay, you keep expanding and you will find that so many terms will become 0. So this will come out to be D 1 plus PQR. Okay, D dash equals to 1 plus PQR. D option. So how do you split it? Very easily. First split the first column. So there you will get A1, A1, A2, A3. Then second, third column will be same. And then from the second, you will get B1, B2, B3. You can take this P common. So P will be outside and this will be same. So like that, if you keep expanding, this will be your D dash in terms of D, because you can see that A1, A2, A3, B1, B2, B3, C1, C2, C3, C3 you will get from here. Okay, let us move to next and last question for this session. Here, alpha, beta, gamma are roots of this equation. Okay, and here you can see that alpha plus beta plus gamma is sum of roots, that is minus p, and alpha, beta, gamma will be your plus, then minus, then plus q by a, and that is 1 actually, q by 1. And alpha, beta, beta, gamma, and gamma alpha will be 0 because there the coefficient of x is 0. So with this information we shall try to proceed. So from there, here we have to find the determinant value of this. You can take alpha, beta, gamma common. Sorry, you can take 1 by alpha, 1 by beta, 1 by gamma. Or better, if you multiply by here, see, if you multiply by alpha, beta, gamma inside and outside also. So outside you multiply by alpha, beta, gamma, and inside you multiply the numerator value, that will be alpha, beta, gamma. So in the first row, so it will become your beta, gamma, here alpha, gamma, here alpha and beta. Okay, and here it will become alpha, gamma, alpha, beta, and beta, gamma, here alpha, beta, and beta, gamma, alpha, gamma. Okay, and you will need 3. You will need to multiply this 3 times inside, because in the first row, second row, and third row, 1 by alpha, beta, gamma, and inside alpha, beta, gamma. So now you can just apply this operation, R1 equals to R1 plus R2 plus R3. So here you will observe that 1 by alpha, beta, gamma over 3. Inside you will get 0, 0, 0. Because when they get added, this will come out to be 0. And this will be as it is. So that is not affect any value. So this will be finally 0. Okay. So this is the value of the determinant. Here you can see that none of the option gives you 0. So this will be your correct option. So today we will wind up at this question. In next session, we will discuss other 10 questions of the section B. I hope you enjoyed the session. So, thank you. See you again.